Hi, today I'm going to go over two items. The first item is how to configure a floating or redundant static route, and the second item is how to configure load balancing over two static routes in this case. This is just really covering on static routes. Routing protocols usually make this happen automatically. If a link is considered to have the same metric, it'll load balance. If not, it'll only one route will get inserted into the routing table. As soon as that route is no longer reachable, the second route with the higher metric will be inserted into the routing table. So to begin, I have not configured any of the routers here. Router 1 is and router 2, these are 3600 series routers on GNS3 emulator, and for the sake of IP version 6 becoming more and more popular, and a lot of people actually are not very familiar with it, I figured that I would do this for both IP version 4 and IP version 6. So let's begin. Let's see, first thing here, router 1, let's enable, and let's just configure our IP addresses. So config T, and for the time being I'm only going to configure the IP version 4 address just to make this I'll do the same thing with IP version 6, and it'll be sequential. Let's go to the other router. And then the serial 01 interface. And then let's just verify connectivity before we go any further. Alright, so now that we have our connectivity, let's kind of take a look. Let's see. First, let's create a route that we would like to reach over the serial 00 link. Now we can pretend that router 1, let's say, is our router, and router 2 could be the service provider router. So usually, you know, in a small environment where you don't have BGP going and you're not receiving all the routes from your ISP, or, you know, summarized routes from your ISP, what we would do is we would just configure a static route out. Now, because we have two links to the ISP over the same router, we will configure the second one for redundancy. So if the first one, the interface goes down or something like that happens, then the second one should get inserted into the route table. So the first one, let's do IP route, a default route, and there's really two ways to do it. We can specify the serial interface or the next hop address, or we can actually do both. Now, for the sake of design, The most efficient way to actually do this, to minimize broadcast traffic on that link, and also to minimize router processing time so it doesn't have to look up which interface it's going out of, would be to do both the serial interface that it's going over and the next hop address. So we would do serial 00 with the next hop address of 1.0.0.2. And then we'll do the secondary route over serial 01 and next hop address of 2.0.0.2. Now we will insert, because this is going to be a redundant route, what we're going to do is we're going to insert a higher administrative distance for this route. The default administrative distance is 1, and let me show you that. So right now, right here, our static default route has a distance of 1, the first number in the parentheses here. This back number is the metric. Because this is a static route, the metric will be 0. So anyways, let's do our second round here, and we'll just do anything higher than 1 is fine. I'll just do 50 just because. Now one thing to notice, even though we enter this route statement, it is not going to appear in the routing table. And don't be alarmed by this. All that really means is that only the best route, or if you're load balancing you may have 2 routes to the same destination, but only the best route to a destination will get inserted into the routing table. So that's really kind of what I wanted to demonstrate. And this is our default route going to any network out to the internet. Now what happens is, if that serial 00 interface goes down, which we'll demonstrate by just shutting down the interface, and we see it go up here or go down, and then we see our backup route get inserted into the route table. So that's really what a floating route is. It's just having a second, or multiple, you may have 5 routes with different administrative distances, and you prioritize on one. Maybe it is a higher throughput link, so you would like, you know, your T1, and then your backup link maybe is only 56K, so you only want to use that when you absolutely have no other type of connectivity. And that is how this gets done. Now let's do the second scenario where we would like to load balance over both. Let's say that we have 2 T1s going out of router 1 going to the provider, and we would like to load balance over them because there's really no point of, you know, wasting or not using one of the links when it has the same potential as the first one. So we will go and remove the second route and then we will insert it again, but we will do it with the same metric as the first one. By default the metric is 1, so all we're gonna do is exclude this 50 at the end, and that should make it come back. So let's go ahead and unshut that serial interface again. And as you see now, both routes are actually inserted into the routing table, and that is because it is load balancing over the both of them. So by default, I believe if Cisco Express Forwarding is turned on, it load balances per source to destination. So, you know, the first host talking to google.com will always go over one link, and then the second host talking to google.com will go over the other link, and so forth. There's just an algorithm that runs that checks source IP and destination IP, and it'll load balance that way. That doesn't guarantee necessarily, you know, that one link will be used exactly the same as the other one, because some users may be doing heavier traffic to their destination than the first. However, this is the way load balancing is done with static routes.